Welcome to the Glassworking shop. Well, the hexagonal assembly was successful and the pull was successful. Here's a still photograph showing how it came out. And no, it's not perfect, but it never is. It's reasonably straight, reasonably untwisted, and close enough to do the next step. I didn't set up the camera outside at the cold saw when I was cutting it into slices, because you've seen it before and it's not that interesting. So here's a still photograph showing the slices arrayed on the ceramic plate before being put into the kiln on the Chipstack Kiln Assembly fixture thingy that I don't have a cool name for yet, but I'm still thinking about it. So everything is just about up to temperature. I preheat the plate and the components to 1500 degrees F, which is right below the softening point of boro. I went through a lot of experiment trying to figure out how hot to preheat it, because I'm fighting a battle here, staying right on the edge of getting hot enough for the glass to fuse, but not so hot that it sticks. And when glass sticks to ceramic, it sticks really good. I think that's why they call it glazing in pottery making. It actually fuses together, and once it sticks, it's impossible to fix. So we're at 1500 degrees. I've got the Mirage hand torch set up with a kind of a slightly oxidizing smallish flame. And I'm going to use the little forklifty thing to remove the pieces and immediately hit them with the torch. First step in the operation is just to get them kind of sort of stuck together. And there they are, more or less stuck together. And I have to be really careful when I'm not paying attention to the torch. I don't want to have the torch running into some sensitive stuff like boiling the cameras or anything while I'm doing this work. So it's a fairly gentle process. I'm trying to get them hot enough to fuse, but not so hot that they distort on their surface or boil. I'm using a lot of sensitive colors. And got a lot to think about while I'm doing this. They appear to be stuck together more or less well enough to proceed. Now, there's always a trade-off in this kind of work. I think I mentioned before how important it is to minimize the number of hot and cold cycles when working with this kind of glass design. And there's always a trade-off. I could have resized these hexagons before cutting them to make them fit together a little bit better, but I can't really do that while remaining hot. I would have had to do a heat-cool cycle for the resizing, then the saw operation. And so what I did instead is just let the pieces be just a little bit a little bit imperfect. They're pretty good, but they're not perfect. So let them be a little imperfect, and then fill up the gaps in this process. And it actually works surprisingly well. So now I'm doing a combination of side pressure and downward pressure to try to fill up the gaps and get everything to compress together. I'm using a special paddle that I made for this job that has a reinforced top on it. Now that almost did stick just a little bit. Has a reinforced strengthening member on the top so that I can apply a significant amount of downward pressure. Now the downward pressure that I'm applying needs to be straight down with no sliding motion. I definitely don't want to do this. It'll smear the pattern absolutely for sure. And yes, I've made that mistake before. Won't make it again. So using the backstop on the fixture, it's sticking a tiny little bit, which tells me that I'm right at the edge where I want to be of getting it hot enough to be workable, but still when it sticks, it doesn't stick catastrophically. It just kind of barely sticks the littlest bit. And after a number of times practicing this method, I've realized that this is the perfect situation. When it just barely sticks the tiniest little bit, that's when I've got everything dialed in just about perfectly. So now, I don't know if you can see in the video, most of those big gaps have been closed up. And I'm being very careful as I'm doing this to not distort the pattern any more than is absolutely necessary, which is another reason that I try to use perpendicular force, either perpendicular or parallel, but never sliding. Just want to try to keep the geometry of this thing as accurate as I possibly can. The center is always the easiest to get fully melted together. The edges are always the more difficult part. The outer edges are by far the most difficult. Right along the outer edge, this is the part that's very, very hard to get melted together, because when I'm trying to get the torch flame on the outer edge is exposed to the air, and I'm overheating my ceramic plate, causing it to degrade a little bit more. Probably time, and once again, I don't know how many people have seen all of my videos. I don't know if this is your first one. I don't know. So I sometimes tend to be maybe a little bit repetitive, just going over basic concepts over and over again. The plate that I'm using is a very special ceramic plate. The ceramic business is a very difficult business to deal with. a lot of the exotic ceramics that are made for industry, that are made for things like semiconductor processing or other high-tech work, they're all custom made, they're all really expensive, they're all really exotic. You can't really just go to the ceramic shop and say, oh, give me a number one off the shelf, because there really aren't that many. When I started doing this, I started using the easy off-the-shelf, what are called kiln shelves, that are very common in the pottery world. And they worked, but had problems with them. They crack, they're rough, the glass sticks to them. Good news is they're cheap. Bad news is it didn't really work that well for me. So then I started looking around to try to find out, well, what would be the perfect material? And many of the websites that I visited didn't really have a shopping cart. They had a notice that said, contact our engineering team for a quote on your custom project. And of course, translated into English, that means it's going to be really expensive. So I did manage to find some ceramic plates in stock. There aren't that many, but I found some in stock at McMaster Carr. Very expensive, but they kind of looked like they worked. Found some on eBay, some Chinese ones on eBay, and kind of goes to show that even when things have the same name doesn't guarantee the same behavior, the same properties. That I bought what was called 99% alumina ceramic and thought, oh, alumina ceramic, they're all the same. Well, the Chinese stuff from eBay came in and it was really shiny, really hard, like a floor tile or a dinner plate. First time even after preheating, first time I touched it with the torch, it exploded violently. And the material that I got from McMaster was also called 99% alumina ceramic, but it had the additional description, easy to machine with ordinary hand tools. And I thought that was kind of interesting. When I got the material was very expensive. And when I got the material, I noticed that it was kind of soft. You could kind of scratch it with a fingernail. You could sand it with sandpaper. It worked pretty well. But McMaster, for those who deal with McMaster, you got to realize McMaster is never the low-cost supplier. They have a great website, they ship really fast, but almost always possible to get it at a lower price. And so, fortunately, when they shipped me the material, they left the label on the packaging. And I discovered the material was made by Zycar Refractory Ceramic. I think they're in New Jersey or somewhere around there. So I contacted them, and sure enough, they had an even better material at an even lower price, and it seems to work really well. Not perfect, but seems to work really well. So, just about finished now with the top side. The top side is always the more difficult side to do. It's looking really good. I see no signs of degradation or boiling. all of my Marini have tiny, tiny air holes in them, and as I'm fusing with this process, it tends to fill many of the tiny air holes, but I've never made one yet that doesn't have a bubble. And of course, I've worked with other Marini artists who say all Marini have bubbles. Embrace the bubbles, love the bubbles. Don't fight the bubbles, they all have bubbles. And so, still want to get it as bubble-free as I can, but there may be a bit of truth to that statement. They all have bubbles. So there we go. I've got what appears to be a very, very nice top surface. So the bottom surface always goes easier, a lot easier. It's almost completely fused at this point anyway. So I'm going to put it back in the little kiln thingy. This little kiln is really underpowered and takes it quite a long time to recover. So I'm going to turn off the camera, let the kiln recover, and then come back in a few minutes. Okay, the kiln is back up to temperature, and I think I've said this before, maybe someday I will try to figure out a way to either buy a better kiln, build a better kiln, have one custom made. I don't know. I'd like something that recovered a whole lot faster so I could get back to work without waiting. But anyway, we're back up to temperature, and I'm gonna do the side 2. Okay, ready to go on side 2. Side 2 is a lot easier than side 1. So a little more about the ceramic substrate. Oh yeah, that's looking really good. It's almost completely perfectly fused. Almost don't need to do anything to it. Got a little bit of trouble around the edges, but mostly looks really good. The ceramic is real. This ceramic that I'm using from Zycar Refractory Ceramics is really, really good, but not perfect. And I still get varying degrees of sticking depending on how hot I get it. Also, different colors tend to stick differently. The transparent colors and the clears tend to stick worse than the solid colors, the opaque colors. But when I first got this material, I tried using it just as it came, and it worked, but I was looking for, I'm always looking for a better answer, always looking for, hey, what can I do to try to keep it from sticking? And I've read that various different shelf primer, kiln wash, other sorts of material that can be mixed up in a kind of a wet slurry and applied to the ceramic will help prevent sticking. So the first thing that I tried was the shelf primer material that came with the Paragon Caldera kiln. That's what this guy is, the Paragon Caldera. It's sold as a high fire ceramic kiln that can reach 2400 degrees. And it came with a bag of shelf primer material, kiln wash material. And I tried mixing it up. I noticed that it was very coarse, very much like sand. And when I coated the ceramic plate with it, it started flaking off almost immediately and got embedded in my glass. And because the material was so coarse, it got embedded quite deeply and required a lot of cold working to dig it out. I thought, this is just no good at all. So then I read that there was an alternate material called bullseye shelf primer that's used by soft glass artists who use the fusing method of fusing soft glass in the kiln. And I applied that material, 5 thin coats, very, very, very thin coats, and discovered that I had a lot better result, and that's what I'm using now, is the bullseye shelf primer. The bullseye shelf primer is very fine. It almost looks like flour. It almost looks like a fine powder. And it goes on in a very, very, very thin film, and then you recoat it over and over and over again. And it doesn't perfectly eliminate sticking, but it really helps a lot. And the process is working really, really well for me using this material. So I'm just about done here. It's just about time to do the final little touch-up. And for the final touch-up, I'm going to punty up to it, put it on the NQALHA, finish up the last little edges with a mini torch, and then put it in the squeezer just to make absolutely sure it's as hexagonal as it can be, and then call it macaroni. Say I'm done with this guy. Now, I mentioned fusing because this is a very common soft glass technique of fusing in the kiln. And you might wonder, well, why couldn't I just heat it up to 2400 degrees, which is how hot this kiln gets? Why not just heat it up to 2400 degrees and fuse them together? Well, it doesn't work. That's why. I actually tried that. I tried doing a kind of a sacrificial ceramic, not really a ceramic, more like a mortar. I tried making a sacrificial plate out of high temperature refractory mortar. Put a piece of one of my patterns on it for a test. Tried heating it up to melting temperature, and when you heat a boro chip on a piece of ceramic up to melting temperature, it totally destroys it. The chip wants to turn into a ball. There's some kind of, I don't know, convection currents going on in the glass where the pattern just totally gets mixed up, and just swirls together into a kind of a blob. So I ended up with this kind of wanted to turn into a marble, totally destroyed pattern, not at all anything like reasonable or clean fusing. So that's the answer. It just doesn't work. So prepared a little punty over here, and I'm gonna just kind of punty up to the center. Get everything else back into shape here. Get the kiln turned off. Make sure that my oxygen and propane are turned off. Now, I'm gonna eyeball that guy and see what size of squeezing die might be appropriate. Not that one. I need to wait until the end before choosing the size of squeezing die because the assembly process affects the final size, so I can't really have everything prepared in advance. So it looks like it's going to be 1 5/8. This step isn't strictly necessary. I could just throw it in the kiln right now and be done with it, but they might as well have just a little more control, a little more dimensional accuracy. Okay, so going around in the far flame around the outer edges, and I have pretty much, while I was dicking around getting the squeezing dies ready, I pretty much finished these outer edges, and it looks like they're not even going to need the hand torch. That is actually looking really good. little bit of cupping here going on. Definitely don't want to press the center using the punty, because that will put a great big divot in the middle. So there's the result. I believe I have a success. It's looking really nice. Into the kiln it goes. And the next step, I'm going to come up with some sort of a sculpture base to display this guy. And I'm probably going to make a video of the machining for it, but I'm not sure yet. But the only thing I'm sure of is the Chipstack went well. It was successful. Thank you for watching. It's been fun.